Okay, here's a video for Objective 39. This is in your money textbook. So if you don't have that, press pause, go grab that. Objective 39 starts on page 74 in the money textbook. Objective 39 is very, very similar to Objective 38. It's looking at compound interest. A lot of the problems you're going to be finding multiple answers using a very similar formula and often seeing like which situation is better and it will give you more money. One difference is that they're not going to fill in some of the numbers that they filled in before. We're going to have to plug all the numbers in. But the math itself isn't hard. It's just throwing numbers into a formula. It's just making sure you do the steps correctly, especially if we're just using a phone for our calculator. I posted that extra video on how to use the exponent button on a phone calculator. Again, if you have any questions on maybe your phone looks different or something like that, let me know. I can help you out with that. But let's get taking a look at Objective 39. Number 13 here says, which savings account will earn the most interest on an investment of $52,000 for 5 years? So, depending on how long you put some money in for or how many times a year it's compounded and things like that, your interest rate can be different. So they're giving us 3 different situations here, which are choice A, B, and C. Okay. Now, each one of them the formula is going to be very similar, but there'll be something just a little different. Okay, so let's go through this formula again. It's very similar from what we looked at in Objective 38, but we're going to have to figure out some of these numbers instead of where they put it in, like the number underneath the R they did in Objective 38. We're going to have to figure that out now. So it says B is the balance. Okay, that's what we're going to be looking for, I believe, in all these problems. We'll take a look here as we go. P, that's the same as it has been. That's the principal or the amount that we're putting in. So in this problem, the 52,000 is P. Okay. R is the interest rate written as a decimal. That's going to be different for each choice. We're going to have A, B, and C is a different interest rate. So that's going to change for each choice. We're going to have to look at that. N is the number of times interest is compounded per year. So if it was just compounded yearly, that would be a 1. Okay, and we're going to look at these in a second. But if it was compounded daily, it would be 365, because there's 365 days in a year. And now up here, it's hard to see, but that says NT, or N times T. The N is still what it was here, how many times it's compounded a year, but the T is back to the simple interest type problem. T is the number of years. So here 9 is going to be T. So let's take a look at this problem. We actually have to figure it out for A, B, and C. We have to do each of these and then see which one's better. Okay, because it's asked which one will earn the most interest. Okay. So letter A, there's going to be some parts in all these problems that will be the same. The 52,000 in A, B, and C will be the same. That's the principal. The 1 is part of the formula. That'll be the same. Okay. The T, or the 9, up here will be in all parts. Now that exponent will change because we have to multiply it by something, but that 9 you'll see in each one. All right, so letter A is 5% and compounded annually. So 5% is 0.05. The N is how many times it's compounded a year. Annually means just once a year. So we have a 1 there and a 1 there because that's both the N's. And then the T is for 9 years. Okay. So now you do some order operations. And I didn't show every step in here, so I will do that for a few of these, maybe not every one. I used more of a scientific calculator where you could type it all in at once. Again, our phone calculators, most phone calculators cannot do that. So what I did here first is I divided this. Order operations, we have to look in the parentheses, and then for any multiplication or division. So this divided out is 0.05. Okay. Then order operations would say I have to add these two, so that's 1.05. This 9 is from 1 times 9. Okay. Now if I showed every step, and I'll do that I think for letter C down here, I'll show every step, but I'll talk through it here, so if you want to do it in your calculator you can. You'd hit 1 plus 0.05, so that's 1.05. Then you would have to use, remember the button like that on your calculator. Okay, so you'd have 1.05, hit that button, hit 9. Then just leave that number in your calculator, hit times 52,000. This would be your balance for letter A after that 9 years. Okay. Letter B, it's a lower interest, but compounded 4 times a year. Okay. So all the numbers are the same except the R and the N. So the R is now 0.048 instead of 0.05. The N also is here. You always see the bottom number here, and this number will always be the same because that in the formula that's N. And then the T is still 9. So the first step I did here was I did this multiplication. Okay, so I copied everything down the same. The exponent here is 36. Okay, now if I had a really nice scientific calculator, I could type this in properly and get my answer. If not, I would do this division first in the parentheses, take that answer plus 1, keep that in my calculator, hit the exponent button, and then 36. Again, you're going to get another long decimal, times that by 52,000, and you should get this answer. Okay, so far we know this is less than A, so the interest we earned, even though these are balances, we started out at the same, so this has earned more than this. So letter B at this point in time is out. Okay, and then the last choice is 4.9% interest compounded monthly. Now, once you learn more about interest and compounding, we could have probably eliminated B right away. And the reason why is 4.9 is bigger than 4.8 and it is compounded monthly. The more it's compounded, the better. So if both of those things are true, the interest is better than another choice, and the compounded, how many times it's compounded a year is more. So monthly is 12 times a year. That's more than this. C is for sure going to be more than B. Now we can't say between A and C which one's better without doing the math, because 5 is bigger than 4.9. That's true, so A has an advantage here, but C has the advantage in how often it's compounded. So 12 times over 1 time a year. So anyways, let's do this, and I will show you the steps on typing this in on this one. I'll show you every step. So here, 52,000 is the same, the one's the same, 0.049 instead of 0.048. We divide by 12, okay, because it's compounded monthly, which means 12 times a year. So that N is also up here, 12, okay, and the T is still 9. So the first thing I did is I took 12 times 9, my exponent now changes to 108. Okay, so now I'll try to do this stuff. Sorry if it's not neat, but doing with the mouse. So the first thing I do is I'm going to divide this 0.049 and I'm going to divide it by 12, and that's going to give me 0.052. 4, 0, 8, and then the 3 just keeps repeating, so a bunch of 3's. And that's still to the 108th power. Okay, then I'm not going to type out this 52,000 yet in my calculator. I'm going to take the decimal I have in the calculator, which is this 0.0408333, and add 1 to it. So now I have this in my calculator. So all I have in my calculator right now is what's in the parentheses. Okay, then I'm going to keep that there. I'm going to hit this power button and type in 108. I'm going to end up getting 1.55 something. So I still have this. So it didn't change the number by a lot. 1.5528, and then a bunch of numbers. Okay, now I'm just going to keep that number in the calculator so it's not rounding. And I'm going to times that. This doesn't look like a good 2 here. 52,000. Times that by 52,000, and I get this number that I have here, which out of all the 3 choices is the highest. So that is our answer, choice C. Okay. So that seemed kind of long, but once you get used to it, it's going to be faster. And maybe on these next few problems, I won't show every little step. I'll talk through it and get through them a little faster. So number 14 here, you can deposit $500 into a savings account with a rate of 8.6, compounded semi-annually. Semi-annually means 2 times a year. Someone else deposits $500, so same amount, in a savings account at 8.5, so it's a little less interest, but it's compounded daily. So we can't just look at this and know, because one has a higher interest rate and the other gets compounded more often. So daily means 365 times a year. Okay, and it just asks which account will have the greatest balance. Okay, so 500 is the same in both. The principal, 1 is part of the formula. Interest for the first person is 0.086 because it was 8.6%. Second person, 0.085 because it was 8.5%. Now the difference is the N. Okay, so the R is slightly different, and the N is going to be different. N in this one is 2 times a year, semi-annually, so the 2 there and the 2 there. Here it's 365 times a year, so 365 there, 365 there. So first step I'm going to do, multiply the 2 times 5, so my exponent becomes 10. In this problem, 365 times 5, and exponent becomes 1,825. Now, just by looking at this, it looks like this is going to be so huge that it's for sure got to be bigger, but not necessarily, because the number inside here isn't going to be much more than 1. Okay, so again, I'm not going to show every step like I did up here, but I would divide these two, get my decimal, add 1, it's going to be 1 point something, hit my, remember again, the X to the Y button. Okay, some calculators, most of them for this type will have that. Some calculators will do this button. So if you do have a different calculator, whatever you have in your calculator right here, you would hit one of these 2 buttons, and then to the 10, keep that number in your calculator, hit times 500, you should get 761.75. Again, if you're using a calculator and you're not sure how you should be typing in, try this problem. Don't start a new problem yet. Try this and make sure you're getting this number. Okay, and if you don't, let me know and send me a message, and then we'll work through it. Okay. Same thing here, you divide these two, you're going to get a really small decimal, okay, smaller than you did up here, but you add 1, now you're going to take it to a much larger exponent, so that's where things start getting either evened out or because this decimal is going to be smaller than this one, but then the exponent's bigger. So again, divide, add the 1, hit one of these two buttons to the 1,825. It's still not going to be a very big number, and then times 500, and you get the 764.76, which is just a little bit bigger than the first person. So the answer here is B, the second person's greater balance. Okay. 15, I don't think I'm going to go through 15. It's almost exactly the same as 13. The only things you really have to look at is make sure you know how often it's compounded and making sure you're writing your percentages right. So 8% is 0.08. Compounded annually means once a year. 7.7%, remember you move that twice. 1, 2, so that's 0.077, and it's compounded daily. So 365 goes in for the N. And then C is 7.9%, so 0.079. Your N is 2 because it's compounded semi-annually. So 2 there, 2 there. Now your steps after that are going to be the same. Okay, you get your multiply the exponents to get a new exponent. Okay, did that on all these. Then you will divide, add 1, do the exponent, times the principal. Okay. So in 15, you can see here, even though this had the middle percent of the 3, 7.9 compounded twice a year is better than 8 compounded once a year. Okay, but they're all pretty close. 16, again, I'm not going to walk through step by step. It's very similar to 14. Okay, they give you 2 people. You just have to go through and figure out which one's better. I think we've done all these words now. Monthly means 12 times a year. Quarterly means 4 times a year. Up in the other problem, semi-annually is 2 times a year. Annually is once. Daily is 365. Okay, and let's look at the last page. Again, there's really only 2 types of problems here. They give 6 examples, but there's only the 2 types. So again, 17 is just like 13 and 15. A lot of the same words being used. Okay. In this one, you could probably eliminate certain choices between A and B. We can't knock out C. That been the reason we could eliminate this again, if this makes sense. Otherwise, just do the math and get the numbers. But they both have the same percentage. If 2 things have the same percentage, the one that's compounded more is going to be better. So without doing the math here, they're both at 2.2, but this is compounded more. So B is for sure going to be more than A. Okay. Now we can't do that with B and C though, because this has a higher interest rate than this, but choice C is compounded more, so it could end up being more. Now in this problem, B ends up being the better one. Okay, and A is actually better than C, but we knew B was bigger than A, so we knew A wasn't the choice. So, and 18 again is just like 14 and 16. Okay, one thing to make sure of in this one that I think is slightly different than 14 and 16. Every problem we've done up to this point had the principal the same. Okay, now just make sure in this one, that's one thing that's different here. This person's going to deposit 7,000. So in their problem, P is 7,000. Okay, this other person is going to not much difference, but it's 7,090. Okay, the interest rates are the same. Okay, how many times it's compounded is different. The first person is monthly, so that's 12 times a year. Second one's annually, so that's 1 time a year. Okay, so that's the only difference with number 18 than the other ones. So I didn't walk through all 6 problems, but I don't think we need to since we're already at 20 minutes in the video. These are the 2 main ones, and the rest of the problems are basically just like that. Okay, so when you get through watching this video and getting through objective 39, you're going to go to your workbook. This is a required objective for Yale. It's an extra credit one for MIT. But here's some practice problems. Again, there's 12 practice problems here. You probably do not need to do all 12. You can maybe get by doing 2 to 4 of these because they're very, all the problems, they're basically 2 types of problems. Okay, then check your answers. That's the main key. When you feel you're ready, then you will move on to the next video, objective 40, and then you will come to this practice 40. 40 is going to be a much quicker, much easier objective. So that'll be in the next video. If you have any questions, let me know.